What we're going to do now is sit down and look at each different type of reticle and learn how to maximize the use of each one of them. First off, we're going to go to a duplex reticle, probably the same reticle that you started out shooting with when you was young. All right, looks something just like this, straight line crosshair, heavy duplex up top and on the sides. All right, now traditionally what we used to do is just zero the crosshairs either at 100 meters, 100 yards, or we'd zero the gun to where it was actually impacting a couple inches high, which would actually give us some kind of a max point blank benefit and would allow us to shoot at targets, 2, maybe 300 meters with a little bit of holdover when we got up to 300 and 400. All right. If you look at the reticle though, we can actually take and turn this reticle into a ballistic reticle. All right. If you actually zero the weapon system here, you can actually now, once you know what this measurement is, all right, there's several different ways to find that measurement. If you have another type of reticle like a mill dot reticle where you can actually line this up now and actually mill the difference from the duplex to the crosshair or all the way from one duplex to the other, then we have a unit of measure. Or you could even take a tape measure out there and figure out exactly what that would actually mean in mils. But once you zero here, let's just say that this is equivalent to 1 mil here and this is equivalent to 1 mil here. All right, what is a 1 mil hold? All right, for the weapon systems that we've been utilizing, a 1 mil hold would be somewhere around 254 meters. All right, so that puts our crosshair at 254. All right, so now what is a 2 mil hold? 2 mil hold is going to be somewhere around 360. So our bottom duplex is now 360. All right, so now instead of just having a crosshair and being zeroed on the crosshair, maybe a couple inches high where we can reach out, but now we're having to fudge. Long range precision is nothing about fudging. We're not trying to guess. We're trying to do something very accurately. So even with a old school reticle, just an old school duplex reticle, we can zero our crosshair here, be zeroed at 254 meters, and then be somewhere around 360 meters out depending on your muzzle velocity. So again, it helps to have the actual PDAs you can run through a ballistic program. And there's a lot of different ones you can actually utilize. Now the problem that you're going to run into is, let's say this is a 3 to 9 power scope. All right, once you have a 3 to 9 and you're running this at full power when you zero the weapon system, when you back that power off, everything's going to start changing. The one thing that doesn't change is your 254 meter zero. That stays constant. Your 100 meter zero up here isn't 100 meters anymore. So if you actually back it out to half power, and what you have to understand, half power isn't necessarily half power on what's marked on your scope. So if you take a 3 to 9 and actually turn it back to 4.5, you would assume that's half power. But you actually need to check it. What you need to do initially is mark top duplex here, bottom duplex here, and then take and turn your scope down until your crosshair is here and the bottom duplex is here. All right, this would actually tell you that now you're exactly half power on that scope. No matter what it says on the ring, this is half power now. So once you get to that, this now becomes your 100 meter zero. Your 254 actually stays the same at all times. But what does that do? Once we're at half power, this is equivalent to a mil, this is equivalent to a mil, now this is equivalent to 2. Make sense? All right, so now we're 1 mil down from our zero here at 254, but now we have 2 mils worth of use past that. So now our bottom duplex is really equivalent now to 3 mils. All right, so a 3 mil hold for your weapon system is going to be somewhere real close to 435 meters. All right, so now when we actually change, we'll move this over here to full power, all right, at 360. But when we are at half power, this here turns to 435. All right, so again, by manipulating the power ring on our magnification, we can actually very accurately turn a standard duplex reticle into something that's more useful, and you can actually reach out to range instead of going, I don't know, I held a foot over his back, that kind of stuff. So now we can actually utilize this, and you can continue to back down your power ring. All right, so as you do that, you can work further down and all these numbers will change. But again, you can go out and shoot it, but it's much faster. Once you know what each line represents in mils, it's pretty fast to run it through a ballistic computer. If you know your muzzle velocity and your ballistic coefficient, your density altitude, you can actually run this through a ballistic computer or ballistic solver and actually have real precise holes all the way out to distance. Yes?
Got a question for you, Todd. If you back it off a little bit more because you're trying to work on work on getting a little bit further with your scope, would your center cross here, no matter what, always stay at 254? It's just that you pick up more mils on the bottom. Is that what's happening here?
Yeah, absolutely. And really, basically we're zeroing here, you know, at 100 meters, but really we're zeroing at 100 meters for 254 meters is what we're doing. That zero is going to stay constant. As you run through your power ring, it's not going to change. All right, so this is old school stuff. This is what we used to utilize, and it's still a really good tool today. All right, now we've stepped up into mil dot reticles. Again, we have the heavy duplex, and the heavy duplex at, you know, at low light actually helps us sometimes see exactly what we're aiming at. The crosshairs, you know, if you're not utilizing illuminated reticles, a lot of times the crosshairs kind of get to where they get washed out and we can't see them. So the heavy duplexes really kind of help us pick up what we're aiming at the time when there's no light. All right, same thing with this. What I decided to do, instead of using a lot of max point blank like we did in the past, or running 500 meter hold over, hold under drills, what we ended up doing was actually zeroing here at 100 meters. All right, if you're working with a mil type turret, you can actually dial 5 mils up and put your 100 meter zero up here at the top duplex. All right, what this gives us, if you're working with a TMA scope, it's 17.2 minutes of angle equals the 5 mils. So if you're running either one, you're going to have to dial. If you're dealing with minutes of angle, you may only have 17 minutes is all you can dial. If you're in a quarter minute, you can dial 17.25. All right, but that gives us the same thing to where we're zeroed up here at the top. Now what this does, instead of doing like a 500 meter hold over, hold under drill, all right, or having a 300 meter zero on your gun and you're actually, you know, up in the top portion with your crosshairs for 100 meter, not your crosshair, but your actual hold. This allows us not to have to do math because that's what it's all made for. So basically what we call this is a poor man's horse. The poor man's horse allows you now, if I'm looking at a target and I say it's 305 meters, I know my mil hole's 1.5, I'm gonna put it right here. It's 1.5 mils down from the top. I know if I'm gonna shoot 400 meters, it's 2.4. So I'm gonna hold here. This would be 305, this would be 400. All right, if I know my holes for 600 is 5 mils, this equals 600, all right? So right now, very quickly, if I already have my dope sheet in my scope cap cover on the side of my gun, or I've memorized my holes every 100 meters out, very quickly, if I say, hey, I got a target at 780 meters, my hole's 8.2, all I have to do is look down and go to 8.2 and hold. So it's a very refined way to do this. Now, the problem that you're gonna run into is when you start getting out here on wind calls. All right, because holding out in space, and that's one of the huge benefits of the horse reticle, is that we always have a refined aiming reference point with the horse reticle. When you're holding out here in space, for one, it's hard to actually know exactly how much you're holding out. The other problem is when you actually think you're holding here and your bullet impacts here, you break that shot, you fall back down under recoil. The next thing you're gonna see is, all right, I see the puff of smoke or I missed my target, now where do I make my adjustment? You don't have any good measurement to go off of. It's not very quick. So a lot of times we have the guys actually go ahead and dial their wind if the wind's blowing like it does out here. So usually, I never tell the guys to ever dial wind, all right? We always hold for wind because things change. In a tactical environment, you may have a mover and you're holding, you know, two mils for a 4 mile an hour mover or 2.2, and you also have wind. So you're holding for both of them, but if that target actually turns around and moves the other way, now you have to start taking it off, and if you've actually dialed it on, now you're reaching up there and jerking stuff off and it's slow, and if the target's moving left and right, you know, it's kind of ridiculous to be dialing. For right now, we're just doing pure holes. This is the only time I actually tell guys go ahead and dial for wind, is when we're actually using a poor man's horse like this. It's still a mil-based system, all right? So we can still use it when we're doing mil relation formulas to figure out how far away the target is. You can actually take the size of the target. If the target's 12 inches, divide it by what you mill it. If you mill the target at 0.8 mils from here to about here, if the target mills that size, the target's 381 meters away, all right? So you can utilize that by going 12 divided by 0.8 mils, all right? Once you do that, times 25.4 will give you 381. Now, if you're working in yards, you'd times 27.778, all right? So you can still utilize this the same way it was meant to be utilized. This is just a more refined method of utilizing a standard duplex. All we did is start adding in dots all the way through. All right, now